Hey everybody, tonight we have a summation where as usual it's tacitly assumed, I guess, that you're not going to use a calculator for this, even though that would be tough all by itself. You'd probably have to write a program. Now the simplest summand would correspond to the index I equals 0, and notice that would imply that the fraction that you see is equal to 1 over 1 plus 1. And that's equal to 1/2, of course. Now, again, y'all, just a basic law of exponents. If I is equal to 0, this exponent is equal to 0 right here. So anything, any base raised to the 0 power is certainly 1, except for b equals 0, I guess. All right, so base raised to the 0 is 1, and that explains just the real easy one to pick off out of this. Now, this 37 over 69 looks pretty tough, but it turns out the constant means nothing. It's just kind of a thinly veiled red herring here. The algebra will simplify this thing immensely, independent of the value of the constant. Okay. Now each of these, let's see, let me write this down also. There would be 666 pairs of terms, one corresponding to a negative index and one corresponding to a positive index, one of the terms in the pair. So there's 668 pairs, and there's certainly 666 pairs, and they're in this form. Definitely in this form, right? For positive indices, it's this one. For negative indices, it's this one. Okay. Now notice you can do kind of a standard multiply by a cleverly disguised version of 1 here. B raised to the I divided by b raised to the I is certainly 1. And then we can take advantage of laws of exponents. Okay. When you do this multiplication against this last term in the pair, in one of the pairs, one of the 666 pairs, let's see, that's b to the I. See what you get? Okay, again, right here, bi times 1 is certainly bi. Now, bi times b to the minus I, okay, that happens. That's just the same thing. Let's see here, let's write it down. bi times b to the minus I. Now, you can think of laws of exponents here where you add the exponents and you get b to the 0. Or slightly more intuitively, you can write this as b to the I over b to the I. Any non-zero quantity divided by itself is equal to 1. That's well-known property of arithmetic. So that's equal to 1. All right. And that's exactly where this 1 comes from. This bi hooked up with this b to the minus I to produce this 1. Okay. And so what we have here, a common denominator, built-in common denominator, and something divided by itself is equal to 1. And so while all 666 of those pairs are just equal to 1. So again, the constant itself has no bearing. The value of the constant has no bearing because the algebra itself simplifies to 1 independent of the value of the constant. Okay, so what this is equal to right here would be the 1/2 that we calculated for I equals 0. Remember, this came from the instance when I is equal to 0. That's the one in the middle. Okay, and then plus the this one, we have 666 pairs that sum to 1, so this would be plus 666. Okay. Now let's see here. You could write this as an improper fraction if you felt like it. 2 times 666 is 1332, I believe, plus 1, so that would be 1333 divided by 2. And some people like to just leave the answer like this rather than writing it in mixed fraction form. Okay, and I believe that's correct, folks. 2 times 666. 2 times 660 is 1320. You add 12 to that, you get 1332. Then you add 1/2, you get 1333. Okay, so this is the solution. All righty, folks. Again, the algebra simplified this constant. Thanks for viewing.